Welcome to determining where f is concave up or down. So the idea here is we're looking for where the second derivative, f double prime, is positive or negative. And so we're going to look therefore, just like we did with the increasing and decreasing, for where it could switch between, or where the second derivative can switch signs. So the trick will be to find the places where the second derivative, f double prime, might switch signs. So specifically where the second derivative equals 0 or is undefined. So this is basically the same process as finding where it's increasing or decreasing. It's just that we're working with the second derivative instead of the first derivative now. So the method, we will find the second derivative then we will determine where the second derivative is equal to 0 or is undefined. So again, these are the only places where the second derivative can switch signs. Then just like when we were doing it increasing and decreasing, we're going to break the domain into subintervals. And the breaks are at the points found in step 2. Oops. Then we'll pick a test point in each subinterval. Then just like when we were doing increasing and decreasing, we'll find the sign of the second derivative at each test point. And note, this sign will apply to the entire subinterval. And then we'll go ahead and determine where the function is concave up and down. So note these are the same steps as for increasing and decreasing. It's just steps 1 and 2 amount to, these two steps amount to finding the critical values of f prime. So we're basically, essentially, we're doing what we did with f, now with f prime instead. It's just the very last step, then we're saying how this relates to f in terms of concavity. So let's go ahead and do a quick example. Our job is to determine where f of x equals 2x cubed minus 3x squared plus 5x minus 1 is concave up and concave down. So the first thing we need to do is find the second derivative. So we start off with f of x equal to 2x cubed minus 3x squared plus 5x minus 1. We find the first derivative, f prime of x, and we get this goes to 6x squared minus 6x plus 5. We find the second derivative. Power rule says that this is 12x minus 6. Now we find where this is either 0 or undefined. We're finding where f double prime of x is equal to 0 or undefined. So in this case, it's never undefined. Again, we're working with a polynomial. Polynomial are always defined, right? Unless it specifies x does not equal whatever. Then we want to find where the second derivative equals 0. We are looking for 12x minus 6 equals 0. And that happens when x is equal to 1/2. Now we are going to go ahead and draw our number line. So we just had one point of interest here, namely x equaling 1/2. So we're just going to have two subintervals. One of our intervals will be from negative infinity to 1/2. And the other interval will be from 1/2 to infinity. Right? We've just broken into two subintervals. And we know the second derivative is 0 at our point of interest. So now we just need to figure out the sign of f double prime on both sides. And so we'll do that by picking a test point. So again, this time around, I'm going to go ahead and write out the steps. So this draw the number line was our break into subintervals step. Sorry, break into subinterval. Now we're going to go ahead and pick test points. So copying the number line quickly, we have our two subintervals. We'll go ahead and pick say x equals 0 on the left side and x equals 1 on the right side. And then we need to find the sign of f double prime at each test point. So again, trying what we already had. We know that f double prime of x was equal to 12x minus 6. So if we plug in 0, we are looking at 12 times 0 minus 6, or negative 6. So you got a negative. And if we plug in 1, we are looking at 12 times 1 minus 6, or positive 6. So we have a positive. At this point, we are going to determine where f is concave up and concave down. So again, drawing our number line one more time. We know that the second derivative started off negative and then passed through 0 at 1/2 and switched to positive after. So again, remember concave down, or sorry, if we're negative, it's a bad thing, so we're frowning. So I'm just going to draw a sad face. And if it's positive, it's a good thing, so we're smiling. So we have that our function is concave down between from negative infinity to 1/2, and then concave up afterwards. So it's f is concave down on the interval from negative infinity to 1/2. And concave up on the interval from 1/2 to positive infinity. So again, it's the same idea in terms of the steps as what we did with increasing and decreasing. It's just we're working with the second derivative instead of the first derivative this time. So it tells us concavity instead.